We are proud to present our Airborne Multistatic Passive Surveillance Technology, also known as AMPS, developed by Toyon Research Corporation for NavAir Topic N68335-24-C-0119. This presentation was prepared by Dr. Justin Lee, an analyst at Toyon. Toyon Research Corporation has been providing the government with cutting-edge solutions in radar systems and electronic warfare since 1980. Some of Toyon's relevant projects include a sensor resource management module to enhance radars for the U.S. Navy, an advanced receiver for localizing distressed emitters for the Department of Homeland Security, and a multi-sensor fusion framework that exploits multipath effects to geolocate jammers for the Air Force. In addition, Toyon developed an expendable active electronic countermeasure subsystem for the Army to improve the survivability of precision-guided munitions and rotorcraft against advanced threats. As an employee-owned small business, Toyon has a dedicated workforce of over 200 staff nationwide, about 90% of whom are in technical roles. The company operates under the NAICS code 541715 and generated $77 million in revenue for fiscal year 2023. Toyon maintains two facilities, one in Santa Barbara, California, and another in Sterling, Virginia, which enable work for special access programs and are equipped with electromagnetic laboratories, an anechoic chamber, and a machine shop. The U.S. Navy has a critical need for detecting and tracking enemy platforms while remaining undetectable under emission control, or EMCON, conditions. In hostile environments, Navy platforms must be able to detect and track targets while minimizing their own vulnerability. Broadcasting active radar signals can potentially compromise the position and safety of these assets, including airborne units like the unmanned MQ-8B Fire Scout pictured here. Solutions to this challenge must achieve reasonably high performance under EMCON conditions. Toyon has developed the Airborne Multistatic Passive Surveillance, or AMPS, software system to address the Navy's need for radar capabilities that can operate effectively under EMCON conditions. Traditional radar systems rely on active emissions to detect and track targets. However, these emissions can be detected by adversary forces, potentially exposing the location and compromising the safety of U.S. Navy platforms. In contrast, Toyon's AMPS technology enables the detection and tracking of enemy platforms without the need for active radar emissions. This allows Navy assets to maintain a high level of situational awareness while remaining undetectable under EMCON conditions. The AMP system is designed to ride along and be hosted on aircraft already equipped with radars or electronic sensing measure systems. This integration approach minimizes the need for additional hardware and allows for a seamless enhancement of existing platform capabilities. AMPS is a software-based solution for multistatic passive radar, enabling the detection and tracking of surface vessels from airborne platforms without emitting any signals of its own. AMPS operates by opportunistically exploiting radio frequency emissions already present in the operational environment. These emissions, referred to as signals of opportunity, include those from marine radar systems and other sources. To detect and localize targets, AMPS employs advanced algorithms to extract target information from signals with power levels below the noise floor. This allows the system to achieve performance comparable to traditional radar systems that rely on active emissions. One of the key advantages of AMPS is its ability to leverage multiple available signals of opportunity simultaneously. By fusing data from diverse sources, the system can potentially provide a more comprehensive and reliable picture of the operational environment. Another significant benefit of the AMP system is its software-based nature, which greatly facilitates integration with a wide range of existing processors and sensors on airborne military platforms. This greatly reduces the need for costly and time-consuming hardware modifications, making AMPS a highly adaptable and cost-effective solution. The schematic pictured here illustrates the basic operating principle of AMPS, showing how the system leverages multiple opportunistic signal sources, denoted by TX, to detect and track surface vessels without revealing the presence of the AMPS host platform. The project is currently funded for Phase 2, following the successful completion of Phase 1 in 2023. During Phase 1, Toyon developed software and algorithms that demonstrated the feasibility of the AMPS approach using satellite signals of opportunity. This laid the foundation for the ongoing work in Phase 2. So far, Phase 2 has progressed according to plan. We have assembled the necessary hardware to collect multiple signals of opportunity, enabling the team to gather real-world data for system development and testing and conduct preliminary experiments. The team has also made progress in algorithm proofing and has specified the processing requirements. By the end of Phase 2, Toyon expects to achieve a technology readiness level of 5 or 6. Offline demonstrations will be conducted using real ship radar data and the targeted computational resources. The real-time requirements for the AMPS system will be finalized based on the target platform provided by the prime contractor. A ground-based demonstration will be conducted to validate that the AMPS system's performance matches the expectations set by offline experiments. Throughout Phase 2, Toyon will continue to refine the AMPS software to minimize size, weight, and power requirements. The AMPS system offers several features that set it apart from traditional radar systems and other passive radar technologies. As mentioned, AMPS does not emit any electromagnetic signals or generate a heat signature, making it difficult for adversaries to detect or counter, and its software-based design eliminates the need for hardware modifications when porting the technology to different sensors, processors, and platforms. Moreover, AMPS has low processing requirements, making it well-suited for low-swap applications. Compared to other passive radar systems, AMPS is expected to be less vulnerable to electronic countermeasures and detection, while having lower maintenance and installation costs. Another advantage is its applicability to multiple domains, including sea, land, and air. In addition, AMPS is expected to achieve longer detection ranges than many other passive radar systems, enhancing situational awareness and early warning capabilities. To maximize its performance and effectiveness, AMPS will aim to use signals of opportunity that have a reasonably high signal-to-noise ratio at long ranges. The system will also leverage signals with specific waveforms that enable better range resolution, as well as signals that are prolific in many areas of interest, facilitating the use of AMPS in diverse operational environments. A ground-based demonstration is anticipated for the end of Phase 2, using Navy-fielded hardware provided by Toyon's current prime contractor. To date, AMPS has been successfully demonstrated offline using real data, with additional data collections proceeding as scheduled. To prepare the AMPS system for deployment, follow-on funding will be necessary. This funding will support more extensive field experiments and enable airborne and real-time demonstrations, which are essential for validating the system's capabilities in its intended operational environment. Toyon is also considering a partnership with a provider of specialized sensing hardware that can operate in more diverse frequency bands. This collaboration would expand the range of signals of opportunity that AMPS can leverage, enhancing its versatility and effectiveness. The expected transition targets for AMPS include Navy maritime patrol and surveillance platforms, as well as any manned or unmanned platforms that are already equipped with radars or other sensors for signals intelligence, electronic warfare, or ISR. AMPS has a wide range of potential applications across both military and civilian domains. In the military, AMPS can enhance maritime patrol, surveillance, and reconnaissance capabilities. AMPS also has potential applications in missile and artillery guidance. In airborne, early warning and control, the system can provide an additional layer of situational awareness, complementing existing radar systems. For unmanned aerial vehicles, AMPS can support navigation and control functions, enabling these platforms to operate more autonomously and with reduced reliance on active emissions that could compromise their stealth. Moreover, AMPS can serve as an anti-stealth technology, helping to detect and track low observable targets that might otherwise evade traditional radar systems. Beyond military applications, AMPS also holds significant potential in the civilian domain. In air traffic control, the system can provide an additional layer of safety and situational awareness. AMPS can also support weather monitoring efforts, contributing to more accurate and timely forecasting and early warning systems. In search and rescue operations, the system's ability to detect and locate targets without relying on active emissions can be invaluable in locating missing persons or vehicles. Likewise, it could be invaluable in wildlife tracking and monitoring, as well as border security and maritime surveillance. As Toyon continues to develop and refine AMPS, we will consider opportunities to transition the system and forge partnerships that can help to maximize its impact and value. AMPS is expected to be versatile and adaptable, allowing it to be implemented for a wide variety of fielded sensors and making it a valuable asset for organizations across multiple industries and operational domains. Moreover, because AMPS is entirely based on software and algorithms, it can be licensed to other contractors and tailored to meet the specific needs and requirements of each system. This flexibility enables Toyon to collaborate with a broad range of partners and clients, delivering customized solutions that address their unique challenges and objectives. The algorithmic framework at the core of AMPS is applicable to several classes of signals of opportunity if other contractors can provide the necessary hardware to handle the frequency diversity. This opens up exciting possibilities for collaboration and innovation. Our transition objectives are multifaceted. First, we aim to insert our technology into existing systems owned by the Navy or other contractors while securing patents for the algorithms we develop. We also seek to increase interest from potential partners and clients by offering customized solutions that meet the unique needs of each application or industry. By demonstrating the value and effectiveness of AMPS across a range of operational scenarios, we hope to attract a diverse array of collaborators who can help to further advance and refine the technology. Another possibility is to license our technology to other contractors and assist them in fielding the system under their own business label. To support these efforts, we are actively seeking funding for more field experiments through demonstrations of our technology's effectiveness during the currently funded Phase 2 effort. We are interested in developing relationships with key stakeholders in both the military and civilian sectors to better understand how we can serve their unique needs. Thank you for your interest in Toyon's airborne multistatic passive surveillance technology, also known as AMPS. To learn more, please feel free to connect with Dr. David Boutte, the primary contact and principal investigator of this contract, and visit our website at www.toyon.com.